Hey guys, today we are going to start our last unit, and today we're going to talk about vectors. So those of you who have had physics are probably going to have a little bit easier time. You've probably heard of vectors and seen vectors. A vector is a quantity that has both magnitude and direction. So magnitude means it is of a certain length or a certain strength, and then direction means it's going in a direction. It could be traveling north or south or left or right or whatever. But there's direction involved. Examples of vectors include force, so something is getting pushed with a certain amount of force. Gravity, pulling down, and wind. Wind can travel in different directions and can have different strength, 10 miles per hour, 20 miles per hour, or whatever. Okay, it's customary to represent a vector by using an arrow. The length of the arrow represents the magnitude of the vector, so the longer the arrow that they draw means the stronger the magnitude is. And then the arrowhead, the little arrow right there, shows you which direction the vector is traveling. So today we're going to look at vectors geometrically. We're just going to pretty much be drawing some pictures. So a geometric vector can be written as it's what's called a directed line segment. So you've got a line segment. It starts at P, it ends at Q. So this is your initial point, this is your terminal point. So it starts and stops, and then the arrow shows you which direction it's moving. So this is directed line segment PQ. If this arrow was on the other end, then we would call it directed line segment QP. So you start with the initial point and you end with the terminal point. Okay, so that's an example of a directed line segment. A lot of times we also use just lowercase letters. So if you look down here, you'll see this is vector V. So if you've got some vector that is the same length, same direction as directed line segment PQ, then you can just use this symbol right here. This would be vector V, which is what we usually use. So you'll see V, you'll see W, vector Z. You could use any letter at all to just represent a vector generically. Two vectors, V and W, are exactly equal, which would be vector V is equal to vector W, if they have the same magnitude and same direction. So they have to be the same length and have to be going in the same direction. So if you look at all of these vectors over here, this vector is going 1, 2, 3, 4 to the right, and then it's going up 1, 2, 3. This one's also going 1, 2, 3, 4 to the right, and up 2, 3, 1, 2, 3, 4, up 3. All right, so all three of these vectors are exactly equal to each other because they're going in the same direction and they're all the exact same length of how long they are. If this was a slightly different direction, then they're not equal automatically, even if they have the same length to them. Today, we're going to be talking about adding vectors. Next lesson, we're going to look at adding vectors not geometrically. We're actually going to do it algebraically, but I want you guys to understand what it means to add two vectors together. So this would be the sum of vectors V and W. So this is vector V. So this is the initial point. This is the terminal point. This is where it ends. And then right where it ends, this is vector W, and so we're going to add vector W to vector V. So we draw vector V, and then where we just stopped, we start and we draw vector W, and then we go back to where we started the problem, and we draw a line to where we just ended the problem. So this vector right here is vector V plus W. So your answer when you're adding vectors is this line that we just drew. It starts here and it ends here. Okay, there's the arrow. There's a little arrow on the end right there. Okay, so that would be vector V plus W. This is your answer. Don't just draw this and then draw that and then stop. This is the sum of those two vectors. In a second, we're going to talk about subtracting. You can also subtracting vectors, but subtracting is kind of a obscure way to think about this. The easiest way to think about subtracting vectors first is to think about what negative vector would be. If vector v is a vector, then negative v, or the opposite of v, would be a vector that has the exact same magnitude, so the same length, but is traveling in the opposite direction. So this is vector v. It's a vector that's going up and to the right. So negative v would have the exact same length to it, but this one will be going down and to the left. And when we subtract vectors, that's actually what we're going to do. So when we turn the page, I'm going to show you how to subtract vectors and things like that, but right now we're just talking about it. So v plus negative w. If you wanted to subtract w, you're not going to do that. You're going to think of it as adding negative w, and then that w would just be going in the opposite direction. So here's w. W goes up and to the right. We would have drawn a vector that goes down and to the left. Same length, but travels in the opposite direction. That's what it's going to mean to subtract. All right. The last thing we're going to talk about before we start drawing some pictures here is what it means to multiply when you're talking about vectors. Well, first off, you can't multiply two vectors together. That's not a thing that we're going to be doing. But what you can do is you can take a vector and you can multiply it by something called a scalar. Now, a scalar is something that has magnitude, but there's no direction involved to it. Okay, so examples of scalars would be mass, length, so like how long something is, time. You could talk about the amount of time something's going, but you wouldn't talk about the direction of time. Okay, or temperature. Okay, same idea there. You could talk about how hot or how cold something is, but you wouldn't talk about that temperature as having any kind of direction at all. So a scalar is just a quantity that has magnitude. You could have more temperature, you could have less temperature, but there's no direction involved. Okay, the numbers used to measure scalar quantities are called scalars. The product of a scalar, so some number, and a vector is just, well, look over here. This is vector v. So this is a vector that's traveling 1, 2, 3 to the right and up 2. So there's your vector. The vector 2v would be a vector that is exactly two of these. So you would go 1, 2, 3, 1, 2. Then you go 1, 2, 3, 1, 2. And it would be exactly twice as long. That's all that that scalar does. It just doubles the length of that vector. This is an example of taking a vector and multiplying it by -1. So what's that going to do? Well, it's going to keep the same length. You're just multiplying by 1. But because you're multiplying by a negative, it's going to take that vector and it's going to flip it around so that it's traveling in the opposite direction. And that's all a scalar does. It either lengthens, or if it's a negative scalar, it could kind of reverse the direction of your vector. All right, so finally, here's what we've been leading up to. So in this example, we're going to use the vectors that are over here, and we're going to draw like what these expressions would be. Okay, so this is vector v. So again, you want to kind of notice how it's moving. It's going 1, 2, 3, goes up 2. Okay, that's how you would draw vector v. Vector w is going down and to the right. It goes down 2 and it goes over 2. And then this is vector u. It goes up and to the right. So it goes over 1, it goes up 1, 2, 3, and that's kind of how the direction that vector u is going. Okay, so look at this example. What would 2v plus w look like? Well, this is just a grid. This isn't like, these aren't like ordered pairs or anything. This is just some grid paper that we're going to use to draw this so that we can kind of count these squares. So 2v plus w. So this is vector v, so I'm going to have two of these end to end, and they're going to be going up and to the right. So I'm going to start down here to the left, just because I know I'm going to be traveling this way. So vector v is 1, 2, 3, 1, 2. So 1, 2, 3, 1, 2. That is vector v. But I need another one. So 1, 2, 3, 1, 2. That would be 2 vector v's. And then I need a vector w, which vector w goes 1, 2, and 1, 2. Okay, so again, where I just ended, wherever you start, you just keep traveling. So you travel up again, and from here, I'm going to go down 2, I'm going to go over 2, because that's what vector w does. And that's my picture. Now, I'm not done. That's not my answer. The answer is the vector that you would have got by starting here and ending here. This is very important. That little arrow right there, that shows you the direction of your answer. This is the vector 2v plus w. Okay, that vector is your answer. Look at the next one, example B. It says vector v, and then it says minus 2w's. So we're going to draw this vector, and then we're going to draw 2 of these vectors, but they're going to be going in the opposite direction. Okay, minus 2. So instead of going down and to the right, this one's going to go up and to the left. That's what negative w would do. So vector v, so again, I'm just going to start somewhere down here. Doesn't really matter. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Vector v. And then I'm supposed to do 2 w's, but going in the opposite direction. So I'm going to go up and to the left. 1, 2, 1, 2. 1, 2, 1, 2. So that's a negative w that I just drew. And then I need to draw another one. 1, 2, 1, 2. That's negative w. Again, I'm not done. This is my answer. The vector that started where I started, it's going to end where I just ended. And I'm even going to label that vector v minus 2w. That's the answer to that problem. Okay? Now, I want you to try C. So I want you to stop the video here in a second. I will tell you, for this to fit, you're probably going to want to start like up here somewhere, up and to the left. If you start down here, you may run off the grid. So start somewhere up here. Okay? But pause the video and see if you can draw this one. Alright, and that's my answer. There's vector v. I added 2 w's, so down and to the right. Down 2, over 2, down 2, over 2. But then I had to subtract a u. So again, where I just stopped with that second w, I needed to, if I was adding u, I would have went over 1 and up 3. Over 1 and up 3, but I wasn't. I was supposed to subtract it. So again, I went left 1, and then I went down 3. And that's where negative u would end. So that's where my little problem ended. So my answer is this vector right here. V plus 2w minus u. Okay? Now take a look at your worksheet. You can try a few of these on your own, and then you can check your answers.